The sky above us is not as predictable as it seems. Sometimes, reality itself appears to glitch, revealing a cosmos far stranger than we ever imagined. We will explore the most baffling recorded anomalies in space observation history, from vanishing stars to mysterious signals that defy all explanation. By the end, you will see the universe through a new lens, understanding the profound mysteries that lurk just beyond our current knowledge. What could cause a star to simply wink out of existence? And are we alone in hearing a one-time cosmic hello? How many of these celestial secrets do you think are still waiting to be uncovered? A cosmic glitch is not a simple equipment error or a fleeting trick of the light. It is a persistent, verified observation that stands in direct defiance of our current scientific understanding, an event where the universe itself seems to break its own rules. These are the moments when astronomers, looking at their data, find something that simply should not be there, or watch as something that should be there suddenly and inexplicably vanishes. They are not failures of our instruments, but profound failures of our predictions. Think of these anomalies as the edges of an old map, the places where ancient cartographers would write, "Here be dragons," to mark the limits of the known world. Today, that warning is written in starlight, pointing us toward the frontiers of our knowledge. Each glitch is a potential doorway to a deeper truth about the cosmos, a signal that our models of physics and reality are incomplete. By studying these baffling events, we are not just cataloging curiosities, we are actively expanding the boundaries of human understanding. This foundational idea sets the stage for the very first documented anomaly that truly shook the world of astronomy to its core. Long before powerful telescopes scanned the heavens, astronomers were already confronting the strange and unexpected. In the late 16th century, the Danish nobleman Tycho Brahe observed a brilliant new star blazing in a constellation where no star had been recorded before. This celestial interloper, a supernova, challenged the deeply held belief that the distant stars were fixed and unchanging. It was a profound anomaly, a crack in the medieval model of the cosmos that helped pave the way for a new understanding. This pattern of confusion leading to breakthrough repeats itself across the centuries. Consider the passionate debates over the so-called canals of Mars, lines that the astronomer Percival Lowell meticulously charted, convinced they were the work of an intelligent civilization. He was wrong, of course, but his observations fueled public imagination and drove scientific interest toward the Red Planet. Then, in the 1960s, a team of researchers detected a radio signal so perfectly regular they half-jokingly labeled it LGM1 for Little Green Men. This was no alien broadcast, but the first discovery of a pulsar, a rapidly spinning neutron star. Time and again, what begins as a baffling glitch, an error in the data or a misinterpretation of a signal, becomes the very key that unlocks a new cosmic truth. This rich history of anomaly hunting sets the stage for our first deep dive, a mystery from the 19th century that remains unsolved to this day. On July 29, 1850, the sun was not alone in the sky. During the middle of a perfectly clear afternoon, a star appeared beside it. This was not a fleeting glimpse or a trick of the eye. From London to the eastern United States, countless credible witnesses, including seasoned naval officers and respected astronomers, saw it clearly. They described a brilliant, steady point of light, shining with an intensity that should have been utterly impossible in the full glare of day. It was not Venus, it was not Jupiter, and it was not any star from our charts. This object, which came to be known as the Great Daylight Star, had no business being there. The immediate scientific reaction was a scramble for a rational explanation. Perhaps it was a comet venturing unusually close to the Sun, its icy core reflecting a tremendous burst of light. Yet no comet was ever recorded in that position. Others suggested a complex atmospheric phenomenon, a perfect lens of air that focused and amplified a distant star's feeble glow. But such an event would be incredibly rare and should have been replicated at some point in the centuries since. It never has. The singular, unrepeated nature of the 1850 event is what cements its status as a true cosmic glitch. It was a one-time error in the sky's normal programming, a celestial guest that appeared without an invitation and left without a trace. This unresolved mystery from the age of visual observation perfectly sets the stage for the next great anomaly, one that emerged from the static of the early radio age. That unexplained daylight star was a ghost in the machine of the human eye, a visual puzzle that vanished before it could be solved. But what happens when the glitch is not seen but heard, captured with cold, hard data by a machine designed to listen to the cosmos? The year was 1977, and the Big Ear radio telescope in Ohio was engaged in a quiet, methodical search of the sky. It was not listening for anything in particular, just sweeping the heavens for any unusual radio whispers. On August 15th, the telescope recorded something that was not a whisper at all. It was a shout. Days later, astronomer Jerry Amon was reviewing the computer printout, a long sheet of paper filled with rows of numbers and letters representing the background noise of space. His eyes locked onto one sequence, a string of characters so intense and so perfectly formed it stood out like a single, brilliant beacon in a sea of static. He circled it in red pen and, in a moment of pure, unfiltered astonishment, wrote one word beside it: "Wow." That single annotation gave the signal its famous name, but its data is what gives it its enduring mystery. The WOW signal lasted for 72 seconds, the exact duration the Big Ear telescope could focus on a single point in the sky. It was a powerful, narrowband radio blast, concentrated on one specific frequency, one that is naturally quiet and is actually protected by international agreement because it is considered ideal for interstellar communication. This signal seemed to come from the direction of the constellation Sagittarius, and its characteristics pointed directly away from any human or natural source we understand. It was not from a passing satellite, not from a rogue military experiment, and not from any known celestial object. It had the precise signature that scientists had predicted for a signal from an intelligent civilization. And then it was gone, despite decades of dedicated searches pointing powerful radio dishes toward that same patch of sky. The signal has never been heard again. It was a one-time event, a single, perfect note played in a cosmic symphony, never repeated. The WOW signal sits in a strange and frustrating category. It is too perfect to easily dismiss as natural phenomena, yet it remains too isolated to ever verify. It is the ultimate cosmic glitch, a blip that suggests a universe that might be shouting, but only once. This tantalizing, unresolved message from the void forces us to confront a profound question. Are we simply not listening correctly, or are we alone in a cosmos that occasionally flickers with false promise? This search for meaning in the static did not end with the WOW signal. It merely set the stage for an even deeper mystery, one that does not come from a single point in space, but from everywhere at once. The WOW signal was a shout from a single point in the void, but some cosmic glitches are even more unsettling because they involve not a sudden appearance, but a sudden and total disappearance. A star, a seemingly permanent fixture in the heavens, can simply vanish. This is not a question of a star dimming or a planet moving behind a cloud. This is the mystery of an object that was there one day and gone the next, leaving behind a profound and chilling silence. The case of Schaeberle's star is a perfect and deeply puzzling example. In 1896, the astronomer John Schaeberle was studying the aftermath of a nova, a star that had recently flared in brightness in the constellation Auriga. He carefully photographed the region, and his plates clearly showed a bright, unremarkable star sitting near the nova. There was nothing unusual about it at the time. It was just another point of light in a sky full of points of light. But when astronomers looked for that same star just 1 year later, it was gone. It had completely and utterly vanished. This was not a mistake. Modern researchers have gone back and re-examined Schaeberle's original photographic plates, and the star is unquestionably there. Yet no telescope since has ever found a trace of it. It did not fade away gradually. It did not explode, as there is no supernova remnant, no expanding cloud of gas to mark its grave. It simply ceased to be. So what could possibly cause a star to just wink out of existence? Theorists have proposed a few exotic possibilities. One is the concept of a failed supernova. This is the idea that a very massive star could collapse directly into a black hole without the cataclysmic explosion we normally associate with such a death. The star's outer layers would fall inward, swallowed by the newborn singularity, leaving behind no luminous evidence of its passing. It would be the ultimate cosmic magic trick, a star disappearing into its own shadow. Another, even stranger, idea is that Schaeberle did not see a star at all, but a gravitational lensing mirage. Perhaps a massive, dark object drifted between Earth and a distant, faint star, its gravity bending the star's light and acting like a cosmic magnifying glass, creating a temporary, brilliant point of light that faded when the alignment was lost. The true answer remains locked away, making Schaeberle's star a ghost in the astronomical record. It forces us to confront a humbling truth. We assume the stars are constant, that the sky is a reliable map. But what if some of those points of light are not stable suns, but transient flickers, cosmic illusions, or objects that can simply switch off? This single disappearance opened the door to looking at other stars that behave in bizarre ways, not by vanishing, but by doing something almost as strange, flickering in patterns so unusual they sparked a modern-day firestorm of speculation about intelligence beyond Earth. While vanishing stars challenge our sense of a permanent cosmos, a star that flickers erratically presents a different kind of puzzle. KIC 8462852, known to the world as Tabby's star, does not disappear. Instead, it winks at us, its light dimming in bizarre, unpredictable patterns that defy every conventional explanation. This mystery was not first spotted by a professional astronomer in an observatory, but by a group of dedicated citizen scientists. They were sifting through the immense trove of data from NASA's Kepler Space Telescope, a mission designed to find planets by detecting the tiny, regular dips in starlight caused when a world orbits in front of its sun. What they found in the data for this one star, however, was nothing like a planet. The dimming events were dramatic, with the star's brightness sometimes plummeting by over 20%. A planet, even a giant one, would only block a tiny fraction of that light. These were colossal, irregular dips with no clear, repeating timetable. It was as if something enormous and shapeless was drifting in front of the star again and again. The immediate and most seductive hypothesis was that of an alien megastructure. The idea, popularized by physicist Freeman Dyson, suggests an advanced civilization might build a vast swarm of energy-collecting panels orbiting their star, a so-called Dyson sphere. Such a structure would block light in just the irregular, massive way we observe. While captivating, scientists quickly looked for more natural causes. The leading theory proposed a massive, fragmented swarm of comets, stirred up by a passing star, creating a thick, dusty cloud that intermittently obscures Tabby's star. Yet, the amount of dust and energy required to produce such extreme dimming stretches this explanation to its limits. Further observations revealed another layer to the mystery. Historical data from old photographic plates suggests that Tabby's star has also been slowly, but steadily, dimming over the past century, a long-term fade that is just as puzzling as the short-term dips. This star is not behaving by any known stellar rulebook. It is a true anomaly of the modern era, a glitch discovered in the digital code of a space telescope, proving that our newest tools are revealing cosmic behavior we do not yet have the vocabulary to describe. It stands as a powerful reminder that some of the universe's greatest secrets are not hidden in the distant past, but are unfolding in real time, in the flickering of a single, unassuming star. This strange dance of light and shadow on a cosmic scale forces us to look deeper, to wonder what other luminous phenomena might be masquerading as something they are not. Tabby's star presents a mystery of something passing in front of a single sun, but what if the entire universe on its grandest scale was being pulled by an invisible hand? This is the staggering implication of an anomaly known as the dark flow. While studying the faint afterglow of the Big Bang, the cosmic microwave background, scientists using the Wilkinson microwave anisotropy probe made a startling discovery. They were observing distant clusters of galaxies, and they expected to see these clusters moving in random directions, their motions driven by the gravitational tug of nearby matter. Instead, they found a coordinated drift. Hundreds of these massive clusters, each containing thousands of galaxies, were all streaming in the same direction at incredible speeds, like leaves caught in a river current that flows through the entire forest. This was not a small effect. The velocities were far too high to be explained by the gravitational pull of any known structure in the observable universe. Every galaxy, every star, every speck of dust we can see simply does not have enough collective mass to cause this motion. The force behind the dark flow must be something from beyond the edge of everything we can see. One radical theory suggests the gravitational tug is coming from a vast concentration of matter that lies outside our cosmic bubble, a region of space that inflated away from our own universe during the Big Bang. Another, even more mind-bending idea is that this flow is evidence of a collision with another universe in the vast multiverse, a cosmic neighbor brushing against our own and leaving a gravitational fingerprint on everything we see. The dark flow is a glitch of an entirely different magnitude. It is not a single star behaving strangely or a one-time signal. It is a systematic anomaly written into the motion of the cosmos itself, a hint that our entire universe might be just one island in an infinitely larger and stranger archipelago of reality. This large-scale peculiarity forces us to look beyond the contents of space and question the very stage upon which the cosmic drama plays out, leading us to one of the most profound and unsettling voids ever discovered. The coordinated drift of entire galaxy clusters hints at forces from beyond our cosmic horizon, but sometimes the hidden reveals itself not through motion, but through an invisible glow. Deep within the vast digital archives of the Spitzer Space Telescope, an observatory designed to see the heat signature of the cosmos, astronomers have uncovered a different kind of secret. They are known as unidentified infrared objects, or UIRO, and they are the universe's cryptic thermal signatures. Imagine looking at a photograph of a dark room and seeing nothing, but then switching on a thermal camera and suddenly spotting the bright, warm imprint of something standing right in the middle of it. That is the essence of a UIRO. These are intense, point-like sources of infrared light, the kind of radiation given off by warm objects. Yet when astronomers point optical telescopes at the exact same coordinates, they find absolutely nothing. No star, no galaxy, no visible source of the heat. It is a glitch between two different ways of seeing the sky. So what are these phantom heat sources? The possibilities are as fascinating as they are varied. One strong candidate is a class of failed stars known as brown dwarfs. These are objects too massive to be considered planets, but not quite massive enough to ignite the sustained nuclear fusion that powers a true star. They are cosmic embers glowing faintly with residual heat and emitting most of their energy in the infrared part of the spectrum. A solitary brown dwarf drifting in the dark between stars could perfectly explain a UIRO, a warm body hidden in the void. Another explanation points to the far edges of the universe. It is possible we are looking at incredibly distant, newborn galaxies that are so thickly shrouded in cosmic dust that their visible light is completely blocked. The dust absorbs the light from their brilliant young stars, heats up, and re-radiates that energy as the intense infrared glow we detect. In this scenario, a UIRO is not a single object, but an entire stellar nursery, veiled from our direct view. Yet the most thrilling possibility is that UIRO represents something entirely new, a class of celestial object we have not yet imagined and do not have a name for. Their existence is a stark reminder of a fundamental truth about astronomy. We do not see the universe as it is, we see it only through the narrow filters of the light we can collect. An object that is dark and cold in visible light can be blazingly bright in infrared, and vice versa. Our understanding of the cosmos is built by stitching together these different wavelengths, and when a piece of the puzzle, like a UIRO, refuses to fit, it reveals a gap in our perception. These infrared ghosts push the very boundaries of classification, forcing us to admit that our catalogue of cosmic objects is still woefully incomplete. They make you wonder what else is out there, glowing quietly in a light our eyes cannot see, waiting for the right instrument and the right curious mind to finally bring it into focus. That unseen infrared glow might be a hidden galaxy or a failed star, but sometimes the phantom in the data reveals itself to be something even more tangible and lonely. Drifting through the dark 75 light-years away is a world without a sun, known as PSO J318.5-22. This object is a planet in every sense but one. It orbits absolutely nothing. Discovered in 2013, this cosmic orphan is a gravitational glitch, a world that seems to defy the standard story of how planets are born. We have always understood planets as children of stars, formed from the swirling disks of gas and dust that circle newborn suns. They are born into a family held by gravity in a stable, warming orbit. But PSO J318.5-22 broke free. It wanders the interstellar void completely alone, a rogue world cast adrift. The mystery, however, deepens when you look at its age and its temperature. This lonely planet is a member of the Beta Pictoris moving group, a collection of stars that are all very young, just about 20 million years old. PSO J318.5-22 shares this youthful age, but that presents a huge puzzle. If it was violently ejected from a young planetary system, as one theory suggests, the process should have left it scorching hot from the gravitational trauma, glowing fiercely for millions of years. Yet when we observe it, it is surprisingly cool for its age. Its temperature does not match the expected profile of a recently exiled world. The alternative is even more radical. Could a planet form all on its own in the cold, dark isolation of interstellar space? Could a cloud of gas and dust collapse directly into a planetary mass object without the central trigger of a newborn star? Current models of star and planet formation say this should be incredibly difficult, if not impossible, for an object of this size, so we are left with a world that does not fit. It is too cool to be a standard ejected planet, and its existence challenges the very mechanism for an isolated birth. It is a celestial paradox, a gravitational anomaly that forces us to rewrite the rules. PSO J318.5-22 is more than just a lonely world, it is a key. Its existence suggests that our galaxy might be filled with countless such rogue planets, dark, untethered worlds silently sailing between the stars. This single discovery expands our imagination of what a planet can be, proving that some of the most fascinating worlds are not held in the light of a sun, but are lost in the profound and endless dark. Those lonely rogue worlds drift in the dark, but at the very heart of our own galaxy, a monument to pure power stands unseen by human eyes. In 2010, scientists working with the Fermi Gamma Ray Space Telescope unveiled a discovery of staggering scale. They found two colossal bubbles of energy, each one a perfect lobe of a vast, invisible hourglass that stretches for 50,000 light-years, with the center of the Milky Way at its waist. These are the Fermi bubbles, and they are not made of gas or dust as we normally picture them. They are structures of pure force, glowing with the most intense form of light in the universe, gamma radiation. To visualize their immensity, imagine holding a dinner plate edge on. Our entire galaxy is that plate, a spinning disk of stars. Now picture two glowing orbs, one above the plate and one below, each one reaching a quarter of the way across the visible sky. This is the true scale of the phenomenon, a pair of cosmic lungs breathing energy into the void. The existence of such enormous, symmetrical structures forces a difficult question. What kind of event could possibly leave a 50,000 light-year tall scar on our galaxy? The prime suspect is the supermassive black hole that lurks at the galactic center, known as Sagittarius, a star. This gravitational monster is currently quiet, but the Fermi bubbles could be the fossilized remnant of a past feeding frenzy. Perhaps millions of years ago, a vast cloud of gas or even a star wandered too close and was torn apart. As the black hole devoured this meal, it could have belched out twin jets of energy and particles at nearly the speed of light, inflating these colossal bubbles over cosmic time. Another possibility points not to destruction but to creation. The galactic center is also a nursery for massive, short-lived stars. A sudden, intense burst of star formation, followed by a wave of supernova explosions, could have pumped enough energy into the galactic halo to blow these gigantic bubbles. Yet the sheer size and perfect symmetry of the structures make some astronomers lean toward the black hole explanation, as such clean, bipolar outflows are a hallmark of active black holes. The Fermi bubbles are a galactic glitch of a different kind. They are not a fleeting signal or a single vanishing star. They are a permanent, high-energy feature of our cosmic home that we simply failed to notice for so long. They reveal that our galaxy's quiet, spiral disk is just part of the story. Above and below us lies the evidence of a violent, eruptive past, a cycle of death and rebirth on a scale we are only beginning to comprehend. This discovery steers us away from the familiar and toward the most extreme and energetic phenomena in the cosmos, where the very laws of physics are pushed to their breaking point. Deep in the silent expanse beyond the planets, two robotic explorers began to drift off course. Pioneer 10 and Pioneer 11, having completed their missions to Jupiter and Saturn, were now coasting on trajectories that would carry them out of the solar system forever. Yet as scientists tracked their paths with exquisite precision, they noticed something was subtly wrong. both spacecraft were experiencing a tiny, unexpected, and constant acceleration, a minuscule tug pulling them back toward the Sun. This was the Pioneer anomaly, a navigational glitch so small it was almost imperceptible, yet its implications were immense. The deviation was a whisper against the roar of orbital mechanics, an extra push equivalent to just 1/10,000,000th of the gravity you feel on Earth. But in the pristine vacuum of interplanetary space, where the laws of gravity and motion are supposed to reign supreme, even a whisper can sound like a shout. For decades, this tiny anomaly refused to go away. It was a persistent data point that did not fit the model, a suggestion that our understanding of gravity itself, the very force that orchestrates the cosmic dance, might be incomplete. Perhaps there was some unknown mass in the outer solar system exerting a pull, or maybe a correction to Einstein's theory of general relativity was needed to explain this gentle, mysterious drag. The anomaly became a tantalizing clue, a potential doorway to new physics hiding in the dark. The ultimate resolution, however, was not found in the stars but in the spacecraft themselves. After years of painstaking analysis, a team of researchers determined that the culprit was heat. Not the heat of the Sun, but the gentle, uneven warmth radiating from the spacecraft's own electronics and their nuclear power sources. This anisotropic thermal radiation, a slightly lopsided emission of infrared photons, acted like a tiny, continuous thruster, providing just enough of a push to account for the anomalous acceleration. The mystery was solved not by rewriting the laws of physics, but by accounting for an engineering detail that had been overlooked. The Pioneer anomaly story is a profound lesson in scientific humility. It demonstrates that the universe's glitches are not always grand cosmic revelations. Sometimes they are subtle hints that our models, even the most brilliant ones, are not yet complete pictures of reality. It forces us to ask what other tiny deviations we might be missing in the data, what other whispers from the dark are waiting to be understood. This meticulous search for answers in the smallest of signals paved the way for an even deeper probe into the fundamental nature of the cosmos, one that would reveal not a flaw in our engineering, but a fundamental shakiness in the fabric of reality itself. That gentle nudge on the Pioneer spacecraft was a mystery measured in millimeters per second, but some cosmic glitches are measured in millions of light years of nothing at all. Gaze toward the constellation Boötes, and you are looking directly into one of the largest and most unsettling structures ever discovered, a region of space so profoundly empty it has been called the Great Void. This is not a simple patch of dark sky between stars. The Boötes void is a spherical chasm in the cosmos, a staggering 330 million light-years across. To grasp that scale, if you placed our Milky Way galaxy at its center, the nearest edge of this emptiness would be so far away that the light from our own galaxy would take 165 million years just to reach it. Within this incomprehensible volume, the expected population of galaxies is almost entirely missing. According to our standard models of how the universe evolved after the Big Bang, matter should have clumped together in a vast, web-like structure with great walls of galaxies surrounding immense bubbles of empty space. The Boötes void, however, is not a bubble. It is a cavern, where astronomers would predict 10,000 galaxies or more. They have found only a few dozen lonely island universes drifting in an ocean of near-total blackness. This is a glitch in the very fabric of cosmic structure. So how could such a colossal nothing come to be? One possibility is that it is simply a statistical fluke, a rare but possible gap in the cosmic web, the universe's equivalent of a massive, naturally occurring desert. Yet the sheer size of the Boötes void pushes the limits of that explanation, making it an incredibly unlikely accident. Another, more profound idea is that this void is evidence of a much more complex and violent process in the early universe. Perhaps it is the scar of a titanic collision with another universe in the multiverse, a cosmic bubble that brushed against our own and swept matter away from a vast region of space. Or maybe it is the imprint of an early phase of cosmic inflation, a period of faster-than-light expansion that left behind pockets of startling emptiness. The existence of the Boötes void forces a fundamental reconsideration. We have long assumed the universe is roughly the same everywhere when you look at it on a large enough scale, a principle known as homogeneity. But this great nothingness challenges that comforting idea. It suggests that the distribution of matter might be far more lumpy and irregular than our models allow, that the cosmos might be woven with threads of something and patches of near absolute nothing on a scale we are only beginning to map. This great emptiness is not just an absence, it is a presence, a silent question mark hanging in the sky that asks us what other structural oddities might be hiding in plain sight. Even a cosmic lighthouse can have a power switch. Pulsar B 1931+24 is not just a pulsar, it is a celestial metronome with a baffling and deeply irregular rhythm. For about 1 week, it behaves perfectly, spinning rapidly and beaming out a powerful, predictable lighthouse sweep of radio waves across the galaxy. Then, without warning, it simply stops. Its signal vanishes completely for roughly 1 month, leaving radio telescopes pointed at an empty patch of sky, listening to nothing but the usual background static of the cosmos. After its long silence, it switches back on again, resuming its regular pulse as if nothing had happened. This bizarre on-off cycle repeats with a strange regularity that is itself deeply irregular. It is a timing glitch of the highest order, a fundamental breakdown in our understanding of how these objects are supposed to operate. A typical pulsar is the corpse of a massive star, a rapidly spinning neutron star with a magnetic field trillions of times stronger than Earth's. This incredible combination acts like a dynamo, generating beams of radiation that sweep through space, and we detect a pulse every time one of those beams crosses our line of sight. The clockwork precision of these pulses is what makes pulsars so useful. They are the universe's most accurate timekeepers, but Pulsar B 1931+24 is a broken clock that fixes itself every 5 weeks. So what could possibly cause a stellar engine of such immense power to shut down so completely and so regularly? The leading theory points to a complex and unseen dance between the pulsar's powerful magnetic field and the environment immediately surrounding it. One compelling idea is that this pulsar is periodically choking on its own fuel. It might be pulling in a thin stream of gas from a companion star or from the interstellar medium. For a week, this gas flow is just right, feeding the dynamo and allowing the radio beams to shine. But then, the influx might become too dense, effectively short-circuiting the process that generates the radio waves and causing the emissions to cease. After a month, the pulsar's own radiation pressure or wind might blow this excess material away, clearing the blockage and allowing the signal to turn back on. Another possibility is that we are witnessing a fundamental reconfiguration of the pulsar's own magnetic field, a star quake that temporarily closes the magnetic portals through which the radiation escapes. Whatever the cause, this intermittent pulsar forces us to admit that our models of these extreme objects are still too simple. It reveals that a pulsar's relationship with its environment is far more dynamic and fragile than we ever imagined. This single, unpredictable beacon makes you wonder how many other cosmic clocks are ticking with secret, hidden rhythms, their true patterns waiting for a patient observer to finally notice the silence between the beats. The universe's chemistry holds secrets we are only beginning to decipher. Drifting in the constellation Monoceros, a celestial structure known as the Red Rectangle Nebula presents a spectroscopic puzzle that has stubbornly resisted explanation for decades. At first glance, it appears as a geometric form of glowing gas, a beautiful and unusual cosmic artifact, but its true mystery is not in its shape but in its light. When astronomers break that light down into its constituent colors, creating a spectrum, they find a series of bizarre, unexplained emission bands glowing in the red part of the spectrum. This phenomenon is called extended red emission, and it is a complete spectroscopic glitch. These bright bands do not match the signature of any known atom, molecule, or ion we have ever studied in a laboratory here on Earth. It is as if you were listening to a symphony and heard a beautiful, recurring chord that used notes from no known musical scale. The orchestra is playing, but the instruments are alien. For years, scientists have proposed theories to explain these ghostly bands. The leading candidate involves a class of complex, carbon-based molecules known as polycyclic aromatic hydrocarbons. These are essentially large, floppy molecules made of interconnected rings of carbon and hydrogen, thought to be common in space. Under the intense ultraviolet light from the nebula's central star, these molecules could be fluorescing, re-emitting that energy as the mysterious red glow. Yet, laboratory experiments have struggled to perfectly replicate the exact pattern of bands we see in the red rectangle. Another idea suggests a process called triboluminescence, where light is emitted from crystalline materials under stress, perhaps from tiny silicate grains being shattered by radiation. But this, too, remains unconfirmed. The enduring enigma of the red rectangle spectrum is a profound reminder of our chemical ignorance. We tend to think of space as filled with simple, well-understood ingredients like hydrogen and helium. But this nebula suggests the interstellar medium is a vast, cosmic laboratory brewing complex and exotic compounds we have not yet learned to identify. It forces us to ask what other molecular secrets are written in the light of distant nebulae, waiting for us to finally crack their code. That unresolved chemical signature is a ghost in the light, but some of the universe's greatest secrets are written in the dark. Drifting silently through the halo of our own Milky Way, a vast cloud of primordial gas known as HVC 127-41-330 presented astronomers with a gravitational paradox. It was a high-velocity cloud, a common enough feature, but this one was different. It contained an immense amount of neutral hydrogen gas, more than enough raw material to birth millions of stars. Yet when telescopes scanned its location, they found nothing. No stellar nurseries, no young blue stars, not even a single, faint red dwarf. It was a ghost ship adrift in the Galactic Sea, a structure with all the mass of a small galaxy but none of the light. This made it a prime candidate for something theorists had long predicted but never conclusively found: a dark galaxy. A true dark galaxy would be a gravitational glitch of the highest order, a structure held together not by the stars within it, but by the invisible scaffolding of dark matter. Its identity seemed to hinge on a simple question: why had this massive reservoir of gas never ignited into starlight? The most tantalizing possibility was that it was a cosmic failure, a galaxy that simply never got started. Perhaps its dark matter halo was too diffuse, never providing the gravitational squeeze needed to collapse the gas clouds into stars. Or maybe it was a pristine relic from the early universe, a pocket of gas that had remained untouched by the violent mergers and collisions that typically trigger star formation elsewhere. It was a fossil, a glimpse into what the cosmos was like before the first stars switched on. But the mystery soon deepened. Subsequent, more sensitive observations revealed a handful of extremely faint, ancient stars mixed within the cloud. This discovery shattered the perfect dark galaxy hypothesis and opened the door to other explanations. Maybe HVC 127-41-330 is not a galaxy at all, but a tidal remnant, a long, shredded ribbon of gas and stars torn from a larger galaxy during a close encounter billions of years ago. Its high velocity could be the momentum from that ancient collision, carrying it on a long, lonely orbit around the Milky Way. The true nature of this object remains hotly debated, a celestial Rorschach test where astronomers see either a failed galaxy or a galactic corpse. It forces a fundamental question that challenges our very definition of a galaxy. What is more important, the stars we see or the gravity we cannot? This invisible structure compels us to look at the night sky and wonder how much of the cosmos is not just black space, but black mass, a hidden architecture of dark matter and silent gas that forms the true, unseen skeleton of the universe. Even the most colossal stars can suffer from violent, unpredictable fits. Luminous blue variables represent a rare and unstable class of stellar giants, cosmic behemoths so massive and tempestuous that they barely hold themselves together. They exist in a perpetual state of brinkmanship, where the titanic outward pressure of their own radiation battles against the crushing inward pull of their gravity. For the most part, this struggle results in a tense stalemate, but occasionally the star loses its balance entirely. It does not simply swell and contract gently, it erupts, expelling vast amounts of its own mass into space in a cataclysmic tantrum. The most famous example is Eta Carinae, a star system that, in the 1840s, underwent a colossal outburst. For over a decade, it became the second brightest star in the entire night sky, despite being nearly 8,000 light-years away. It ejected at least 10 times the mass of our Sun in a spectacular bipolar explosion, creating the beautiful homunculus nebula we see today, a cloud of its own guts frozen in time. This was not a supernova, the star did not die. It was a monstrous burp, a stellar glitch of epic proportions. The fundamental mystery is what triggers these specific, non-terminal eruptions. Why does the star not simply explode completely? The mechanisms are thought to involve the star's outer layers becoming so hot and energized that they reach the Eddington limit, the point where radiation pressure overwhelms gravity. This makes the star's atmosphere literally boil off into space, but in a sporadic, chaotic fashion rather than a steady wind. It is a fundamental breakdown in our models of stellar stability, a reminder that for the most massive stars, the path to death is not a quiet fade, but a series of violent, spectacular convulsions. Studying these capricious giants is crucial because they are the likely precursors to the most energetic explosions in the universe, long-duration gamma-ray bursts. Their volatile nature is a direct window into the final, frantic chapters in the lives of stars so large that they fundamentally challenge the peace of the cosmos. Our most trusted cosmic landmarks are not as fixed as we once believed. Cepheid variable stars have long been the gold standard for measuring the vast distances across the universe. These are stars that rhythmically brighten and dim, and the key to their value lies in a beautiful, simple relationship discovered by Henrietta Leavitt over a century ago. The longer the star's pulsation period, the greater its true intrinsic brightness. By comparing this known intrinsic brightness to how dim the star appears from Earth, astronomers can calculate its distance with remarkable precision. These stars became the first rung on the cosmic distance ladder, the fundamental step that allowed us to measure the scale of our galaxy and, ultimately, the expansion of the universe itself. But what happens when the metronome itself begins to drift? Our own North Star, Polaris, the most famous Cepheid in the sky, is doing exactly that. Its pulsation period is not constant. It is changing slowly but surely, year after year. This is not a small measurement error. It is a fundamental anomaly in the behavior of the star, a glitch in the very mechanism we rely on to calibrate the cosmos. The implications ripple outward. If the period-brightness relationship for Cepheids is not perfectly stable, then the distances we derive from them contain a hidden uncertainty. This error then propagates all the way up the cosmic distance ladder, directly affecting our most crucial number in cosmology, the Hubble constant, which describes the rate of the universe's expansion. The debate over why these periods change is intense. Is it a natural part of the star's evolution, a sign of it aging and crossing instability strips in its internal structure? Could the gravitational tug of an unseen binary companion be subtly altering its rhythm? Or are we seeing evidence of internal processes, a reconfiguration of the star's deep layers that changes how it resonates? Each possibility challenges our understanding of these celestial lighthouses. This is more than a stellar curiosity. It is a calibration glitch in the fundamental tools we use to map reality. A quiet reminder that even our most trusted cosmic rulers can have hidden quirks. It forces us to ask a deeply unsettling question. If our primary standard candle is flickering, how much of our map of the universe is drawn with shifting lines? Even the most violent cosmic deaths can leave behind a ghost. The supernova remnant Cassiopeia is a familiar spectacle. A chaotic tapestry of exploded star debris expanding into space. We have mapped its shockwaves and studied its elemental guts for decades, believing we were reading the entire story of its cataclysmic end. But recent observations have revealed we were only seeing the final, explosive paragraph. Wrapped around this famous wreckage is a vast, faint, and incredibly ancient shell of gas. A structure so subtle it is only visible in the infrared. This is the ghost of Cassiopeia A, and its existence rewrites the star's entire biography. This ethereal shell is much larger and significantly older than the main remnant, meaning it was blown into space not during the supernova, but tens of thousands of years before the star's final death scream. The star, it seems, suffered a massive preemptive eruption, casting off a huge portion of its own outer layers in a violent temper tantrum long before its core collapsed. This is a profound glitch in our models of stellar demise. We thought we understood the sequence of a massive star's death, a relatively stable life followed by a sudden, final collapse. Cassiopeia A's ghost tells a different story, one of a prolonged and tumultuous final act, a series of violent prequels to the main event. It forces us to see supernova not as single explosions, but as the climax of a much longer and more dramatic saga. This archaeological clue, buried in infrared light, suggests that the journey to stellar death is far more complex and eventful than our textbooks ever allowed, a theme we now see echoed in the faint, expanding halos around other supernova remnants. What other final chapters are we missing simply because we were not looking for the ghostly prologue? Some stars do not merely drift through the galaxy, they flee it. These are the hypervelocity stars, cosmic runaways hurtling through space at speeds so immense they have achieved the ultimate escape velocity, breaking free from the Milky Way's gravitational grasp forever. One of the most famous, known as S5 HVS1, is a stellar bullet rocketing through the void at over 10,000 kilometers per second, a speed so great it will eventually leave our galaxy behind entirely. The most compelling explanation for their origin points directly to the monster at the center of our galaxy, the supermassive black hole Sagittarius A star. The prevailing theory is a gravitational slingshot. Imagine a binary star system, two stars orbiting one another, wandering too close to the black hole's immense gravitational well. The black hole's tide can violently tear the pair apart, capturing one star into a tight orbit while flinging the other away at a phenomenal speed, like a stone from a sling. This three-body interaction acts as a natural particle accelerator, but on a stellar scale, yet the exact mechanics are still being unraveled. How often do these events occur? Are there other, even more powerful ejection mechanisms at work, perhaps involving intermediate mass black holes or interactions within dense star clusters? Each hypervelocity star is a kinematic glitch, a fundamental breach of the galactic speed limit. Their trajectories are not random, they are forensic evidence, carrying with them the imprint of the violent event that created them. By tracing their paths backward across the sky, astronomers can use these stellar fugitives as unique probes to map the extreme gravitational landscape at the very heart of the Milky Way. They are living experiments testing our understanding of gravity itself under the most intense conditions. Their existence forces a deeper question. If stars can be flung out of the galaxy with such force, what else might be escaping our notice? Are there planets or even dark matter structures that have been similarly ejected, forming a hidden population of orphans drifting in the intergalactic dark? The hunt for these unbound stars reminds us that our galaxy is not just a place of serene orbits, but also a cosmic battlefield where gravity can both create a home and violently expel its inhabitants. That same magnetic violence thought to fling stars from the galaxy can also produce signals of startling precision. Deep within the Milky Way, a magnetar known as SGR 1935 plus 25-4 entered an active phase, and as astronomers tuned their instruments to listen, they detected something unprecedented. This was not the expected chaotic static of a stellar tantrum. Instead, the radio waves it emitted were strikingly coherent, arriving in a rapid, repeating, and highly organized pattern. It was like hearing a chaotic jazz drummer suddenly switch to the perfect, metronomic beat of a lighthouse beacon. Magnetars are already among the most extreme objects in the universe, the collapsed cores of massive stars endowed with magnetic fields so intense they could strip the information from a credit card from halfway to the moon. Their typical outbursts are violent and random, fitting their ferocious nature. But these coherent signals were different. They possessed a clean, narrowband quality, a purity that suggested a far more orderly and focused emission process than anyone had predicted. This discovery creates a profound and exciting link between a known local phenomenon and one of cosmology's greatest puzzles, the fast radio burst. These are incredibly powerful, millisecond-long blasts of radio energy that flash from across the universe, their origins debated for years. The coherent radio waves from this magnetar are not identical to those extragalactic bursts, but they share a fundamental family resemblance in their structure. It is as if we finally found a small, nearby volcano that occasionally spits out lava with the exact chemical signature of a mysterious rock that has been falling from the sky for decades. This is a radiative glitch, a fundamental anomaly in how we understand energy to be released from these magnetic monsters. The orderly signal forces a rethink of the emission mechanism itself. Perhaps under certain conditions, the star's incredibly twisted magnetic field lines can snap and reconnect in a synchronized way, creating a natural laser for radio waves. Or maybe the erupting plasma is being channeled and focused by the magnetic field into a tight, spinning beam, much like a pulsar, but powered by magnetic fury rather than simple rotation. This single observation blurs the categorical lines we so carefully draw in astronomy. It suggests that the strange, one-off fast radio bursts from distant galaxies and the periodic outbursts from our own galactic magnetars may be different manifestations of the same underlying physics, a scale of magnetic violence we are only beginning to comprehend. It proves that even within a class of objects we think we understand, the universe can still reveal a new behavior, forcing us to listen more carefully to the signals we thought we had already classified. That same magnetic violence thought to fling stars from the galaxy can also forge worlds of impossible beauty, orbiting a rapidly spinning stellar corpse known as a pulsar. A world called Pulsar J1719-1438b defies every expectation of what a planet should be. It is not a rocky sphere like Earth or a gas giant like Jupiter. This world is, for all intents and purposes, a diamond of cosmic proportions. The story of its creation is a tale of celestial cannibalism and violent rebirth. It began as a binary star system, two stars orbiting one another. One was more massive and lived its life quickly, exploding in a supernova and leaving behind the dense, spinning pulsar. This new pulsar then began to feast upon its companion, using its immense gravity to siphon away layer after layer of the neighboring star's gaseous envelope. Over billions of years, the pulsar completely stripped the star, leaving behind only its naked, compressed core, an object made almost entirely of crystallized carbon. This is the diamond planet we see today, the glittering heart of a murdered star. Its existence is a profound glitch in our planetary formation models. We thought planets formed from the gentle accretion of dust and gas in a protoplanetary disk around a young star. This world was not born from that peaceful process. It was forged in a stellar cataclysm, the remnant of a violent, intimate dance between two stars that ended with one consuming the other. This forces us to expand the very definition of a planet to include objects born not from creation, but from destruction. What other impossible worlds are waiting to be found, born from similar acts of cosmic violence? The discovery of this diamond globe encourages us to look for other planetary oddities, proving that the universe is not just a place of familiar worlds, but a workshop where catastrophe can craft objects of stunning and alien wonder. Even the diamond planet, forged from stellar destruction, is subject to the same irresistible, invisible pull that governs all things. Our entire galactic neighborhood is caught in a silent, powerful river flowing toward a mysterious destination. For decades, astronomers have known that the Milky Way, along with our local group of galaxies and the entire Virgo supercluster, is not drifting aimlessly. We are all moving at a staggering 2 million kilometers per hour toward a specific point in the constellation Centaurus, a region they call the Great Attractor. The name itself evokes a sense of cosmic purpose, but the reality is a profound gravitational glitch. When scientists pointed their telescopes toward this focal point to see what was pulling us, they found a problem. The amount of visible matter, the galaxies and stars we can actually observe there, is simply not enough to account for the immense force required to move us so quickly. It is as if you felt a powerful current in the ocean dragging you toward a specific point, but when you look, you see only a small rock, not the massive, submerged mountain that must truly be there. This is the central mystery of the Great Attractor, a gravitational anomaly on the scale of superclusters. The force we feel implies a concentration of mass equivalent to tens of thousands of Milky Way galaxies, yet most of it remains completely hidden from our view. The leading explanation points to a colossal reservoir of dark matter, the invisible scaffolding of the universe, clumped together in that region and exerting its gravitational will on everything around it. But our view from within the Milky Way is partially blocked by the thick dust and stars of our own galaxy's central bulge, a cosmic irony that leaves the heart of the Great Attractor frustratingly veiled. Unraveling its true nature is more than an academic exercise. it is key to mapping the true distribution of matter in our local universe. The Great Attractor is not a solitary mystery. Its pull is part of an even larger flow, suggesting that there may be structures beyond it, even more massive and hidden, orchestrating the motion of galaxies across hundreds of millions of light years. This cosmic tug we feel is a humbling reminder that we are not just observers of the cosmos, but passengers on a vast, invisible current, flowing toward a hidden source of gravity whose full story has yet to be revealed. Deep within the chaotic heart of the Milky Way, a clock with a broken mainspring keeps its own erratic time. Just 24,000 light-years away, nestled in the dense stellar jungle surrounding our galaxy's central black hole, a radio transmitter known as GCRTJ 1745-3009 suddenly switched on. For a few minutes, it would become one of the brightest radio objects in the entire sky, a brilliant beacon in the static. Then, just as suddenly, it would vanish into silence. This cycle of brief, intense activity repeated with a strange precision, flaring brightly for about 10 minutes once every 77 minutes, like a celestial lighthouse flashing on a perfectly predictable, yet utterly baffling schedule. And then, after a few months of this reliable performance, it stopped entirely. It fell silent for years, only to briefly reawaken before disappearing once more, leaving astronomers with a profound puzzle. This is the transient galactic center radio source, an object that is not defined by what it is, but by its mysterious timetable. It is a scheduling glitch in the cosmos, an event that refuses to run on any clock we understand. The source's behavior is a direct challenge to our catalog of cosmic objects. It is not a pulsar, as its radio bursts are too long, and it lacks the steady, rapid spin. It is not a flaring star, as the radio emission is far too powerful and structured, and it does not fit the profile of any known type of binary system, where two stars interact to produce periodic outbursts. It stands alone, a class of one, operating on a set of rules we have not yet deciphered. The very intermittency of the source is a major part of the mystery. Why does it activate for a few months and then go dormant for years? What internal process or external trigger flips its power switch on and off on such a grand timescale? One compelling theory suggests we might be witnessing a type of pulsar that is temporarily active, a magnetar or a highly magnetic neutron star whose radio beam only becomes visible to us when its surrounding environment is just right, perhaps when a cloud of plasma occasionally clears to allow the signal to escape. Another idea posits a unique binary system where a compact object, like a white dwarf, orbits a larger star, and their complex magnetic interactions only occasionally align to produce these powerful, clockwork radio flares. But no single explanation fits all the data perfectly. The existence of GCRTJ 1745-3009 is a tantalizing clue that our census of the galactic center is wildly incomplete. We tend to study the sky in snapshots, but this object reveals itself only to those who watch patiently for years. It forces us to wonder how many other phantom transmitters are lurking in the noisy core of our galaxy, blinking on and off on schedules so long and strange that we have simply missed them in the data. This single, intermittent signal suggests an entire hidden population of celestial objects operating in the shadows, their brief, brilliant broadcasts waiting for the right moment to be heard. That erratic galactic signal is a ghost on our doorstep, but a far more profound anomaly is written across the entire sky, a fossil from the very dawn of time. The cosmic microwave background is the oldest light in the universe, the cooled and stretched afterglow of the Big Bang itself. It paints a nearly perfect picture of the infant cosmos, a blanket of radiation that is almost but not quite uniform. Most of the tiny temperature fluctuations in this background hum are exactly what cosmologists expect, the seeds that would one day grow into galaxies and clusters. But one feature stands out as fundamentally wrong. Known as the cold spot, it is a vast circular region of space, billions of light years across, that is significantly colder than its surroundings. It is not just a little bit chilly, it is a deep freeze, a colossal thermal glitch in the universe's first photograph. According to our standard models of cosmic inflation, such a large and intensely cold area is incredibly unlikely to exist by chance alone. It is a statistical outlier so extreme that it demands a radical explanation. One of the most breathtaking proposals is that we are looking at the bruise from a cosmic collision. The theory suggests that in the earliest moments of creation, our universe was not alone. It was one bubble among many, inflating within a greater multiverse. The cold spot, then, could be the scar left when our nascent universe gently bumped into another, separate bubble universe. That collision would have drained energy from the region, leaving behind this permanent cold patch, a fossilized fingerprint of a reality beyond our own. Of course, scientists have searched for more conventional answers. Perhaps the cold spot is not a feature of the background radiation at all, but a mere illusion created by a vast foreground void, a great emptiness between us and the CMB that its light must pass through. Yet, surveys have found only a modest void in that direction, one that seems far too small to account for the profound temperature drop we observe. The cold spot stubbornly resists being explained away. It remains one of the most tantalizing and hotly debated mysteries in modern cosmology. It is more than just a cold patch on a map, it is a potential window. If it is indeed evidence of a multiverse, then this single anomaly rewrites our place in existence, suggesting we inhabit just one cosmic bubble in an infinite, frothing sea of other realities. This faint chill in the ancient light forces us to confront the ultimate question: are we seeing a random flaw in the data, or the first glimpse of a cosmos so vast it defies comprehension? Even the supermassive anchors at the heart of galaxies can be torn from their moorings. The Hubble Space Telescope has captured what appears to be a cosmic crime scene, a trail of newborn stars stretching for 200,000 light-years, a luminous path with a terrifying implication. At its head, racing away from a distant galaxy at phenomenal speed, is a compact object of unimaginable density, a candidate for a runaway supermassive black hole. This is not a simple stellar exile, but a dynamical glitch of the highest order, a gravitational paradox made visible. The scenario begins with a galactic merger, a slow, billion-year dance of destruction as two galaxies collide. At their centers, two supermassive black holes begin to orbit one another, their immense gravity carving a path through the chaos. As they spiral inward, they radiate energy in the form of gravitational waves, ripples in the fabric of space-time itself. If these waves are emitted asymmetrically, the final merger can act like a cosmic rocket engine, kicking the newly formed, even more massive black hole clear out of its galactic home. The starry wake Hubble sees is the ghost of this violence. As the black hole plows through the dense gas clouds of the merged galaxy at supersonic speeds, it compresses the material in its path, triggering the birth of stars in a straight line behind it, a brilliant contrail left by a gravitational cannonball. This observation, if confirmed, is more than just a spectacular discovery. It is direct, visible evidence for the violent recoil caused by gravitational waves, a phenomenon predicted by Einstein's theory, but never before witnessed on such a colossal scale. It forces us to confront a new population of celestial nomads, invisible monsters drifting in the dark between galaxies, each one a ghost from a catastrophic merger. How many of these runaway giants are silently sailing through the void, their pasts written only in the faint, fading light of the stars they forced into being? The idea of a single star cloaked by alien engineering is captivating, but the cosmos has a habit of producing its own natural illusions. Astronomers have since discovered other suns behaving in similarly bizarre ways, demonstrating that extreme dimming is a genuine class of stellar anomaly. Take the young star epoch 204278916, for instance. This stellar infant, still swaddled in its birth cloud of gas and dust, experienced a dimming event so profound it defied easy belief. For a short period, something passed in front of it, blocking a staggering 65% of its light. The shape of the dimming was the real clue. It was not a clean, symmetrical dip like a planet would cause, but a lopsided, jagged curve. The most plausible explanation points to a warped inner disk of dust and debris, a chaotic ring of planetary building material that is tilted and uneven. As this ragged structure rotates, its thickest, most distorted parts can sweep across our line of sight, casting a deep, irregular shadow. These observations reveal a new category of photometric glitch, where the chaotic physics of a young planetary system itself generates signals we might mistake for something more exotic. The universe, it turns out, does not need alien architects to build structures of staggering scale. It can craft them from simple dust and gravity, creating natural megastructures that challenge our imagination and remind us that reality is often the most creative force of all. Floating 250 miles above the Earth, a machine is counting cosmic ghosts. The Alpha Magnetic Spectrometer, mounted on the International Space Station, is not a telescope that sees light, but a detector that feels the invisible rain of cosmic rays, the high-energy particles that constantly bombard our planet. Its primary mission is to search for the fingerprints of dark matter, and it has found something strange, an anomalous surplus of positrons. A positron is the antimatter counterpart of the electron, a particle of antimatter that should be relatively rare in the cosmic sea. According to our standard models, the number of these positrons should steadily decrease as their energy increases, but the data from the spectrometer tells a different story. Above a certain energy level, the positron fraction does not fall away, it rises sharply. It is as if you were sifting through sand and expected to find fewer and fewer gold nuggets the deeper you dug, but instead you suddenly found your hands full of them. This is a particle physics glitch written in the sky, a persistent signal that something is producing far more of these high-energy antimatter particles than our known universe should allow. So what is the cosmic factory churning them out? One compelling source is a pulsar, the rapidly spinning corpse of a dead star. These dense objects act as natural particle accelerators, and a nearby pulsar could certainly be flooding our neighborhood with positrons. Yet, when astronomers map the known pulsars and model their output, the numbers do not quite add up. The energy spectrum of the excess positrons, the precise way their numbers change with energy, does not perfectly match what we would expect from these spinning stellar graves. This leaves the door open for a more profound explanation: the annihilation of dark matter. If dark matter is made of theoretical particles like WIMP, weakly interacting massive particles, then when two of them collide, they could annihilate each other in a burst of pure energy, producing a shower of standard particles that would include electrons and their antimatter twins, positrons. The signal from the spectrometer could be the first indirect glimpse of this invisible cosmic process, the faint fallout from a collision of shadows. Or it could be something else entirely, a previously unknown type of astrophysical object, a natural particle accelerator of unimaginable power hiding in the galactic dark. This anomaly is a perfect example of a modern cosmic mystery, one found not by looking at the sky, but by meticulously counting particles. It reminds us that the universe's greatest secrets are not always written in light, but are sometimes carried on the silent, high-energy wind that blows between the stars. Our search for cosmic glitches has taken us to the edge of the observable universe, but some of the most violent flashes of energy originate astonishingly close to home. High above our most turbulent thunderstorms, in the thin, cold air at the edge of space, our own planet occasionally unleashes a hidden fury. These events are called terrestrial gamma-ray flashes, and they are essentially dark lightning, invisible bursts of the universe's most powerful form of radiation crackling right in our atmosphere. Their discovery was a complete accident. Satellites designed to observe cosmic gamma rays from collapsing stars and merging black holes kept being momentarily blinded by intense flashes coming from the Earth below. At first, scientists thought it was an instrument error, a glitch in the machine, but the data was undeniable. Our own world was creating these titanic outbursts. The mechanism is as fascinating as it is terrifying. Within the enormous electric fields of a powerful thunderstorm, electrons can be accelerated to nearly the speed of light. When these ultra-relativistic electrons slam into the nuclei of air molecules, they screech to a halt, and that deceleration forces them to shed their immense energy in a brilliant, invisible flash of gamma rays. It is a natural particle accelerator operating in our skies, a process we once thought was possible only in the hearts of distant galaxies. This phenomenon completely shatters the comfortable division we had between planetary weather and astrophysical cataclysms. It proves that the same fundamental physics that powers a pulsar or a quasar is also at work, in a smaller but no less real way, inside a common thundercloud. These terrestrial flashes are a humbling reminder that the universe's most extreme behaviors are not always distant abstractions. They are happening right over our heads, a hidden layer of celestial violence woven into the fabric of our own world, forcing us to look at a stormy sky and wonder what other invisible energies are crackling just beyond our senses. Even the most violent flashes from our own atmosphere are just a whisper against a constant, pervasive hum that fills the entire sky. This is the cosmic X-ray background, a diffuse glow of high-energy radiation that comes from every direction. For decades, astronomers assumed this pervasive static was just the combined light of countless distant quasars and active galaxies, each powered by a voracious supermassive black hole. As our telescopes improved, they began to pick out these individual sources, resolving the fog into distinct points of light, but a stubborn problem remained. No matter how many sources they identified, a significant portion of the background refused to resolve. A substantial fraction of this cosmic X-ray glow has no identifiable origin. It is a census glitch in the high-energy universe, a gap in our inventory of the cosmos's most powerful engines. This unresolved background is not an empty signal. It is a positive detection of something, a collective whisper from a hidden population of objects that our current technology cannot see. The leading theory points to the very edge of time itself. These missing X-rays are likely coming from the supermassive black holes that dwell in the hearts of the earliest galaxies, objects so distant and so faint that their light has been stretched and dimmed over billions of years of cosmic expansion. We are hearing the collective murmur of the universe's first monsters, a chorus of ancient behemoths whose individual voices are too quiet for our ears. This unresolved glow is a promise and a challenge. It is a map of our own ignorance, highlighting the specific limitations of our current vision. Future observatories, like the advanced X-ray telescopes now in planning stages, are designed specifically to hunt for these phantom sources. They will peer deeper into the cosmic past than ever before, aiming to resolve this persistent background into a sky filled with individual points of light. The day that happens, it will not just solve a mystery, it will open a window onto the universe's violent childhood, revealing a hidden realm of ancient, energetic phenomena that shaped everything that came after. This unresolved hum is a placeholder in our cosmic story, a silent testament to the chapters we have not yet learned to read. Our own solar system holds a secret at its dark frontier, a gravitational whisper hinting at a world we have never seen. Far beyond the orbit of Neptune, in the frigid expanse of the Kuiper Belt, a collection of small, icy bodies is behaving strangely. Their orbits are not random. Instead, they are clustered together, their paths aligned in a way that suggests they are all being shepherded by the same invisible hand. The mathematics is clear: something massive must be out there, tugging on these distant objects, herding their orbits into a peculiar configuration that defies the gravitational pull of the known planets alone. This is the heart of the Planet 9 hypothesis, a proposal that a large, undiscovered world, perhaps 10 times the mass of Earth, is silently orbiting our Sun in a vast, elliptical path that takes up to 20,000 years to complete. This would not be a simple new planet. It would be a major dynamical glitch in our own cosmic backyard, a fundamental flaw in our senses of the solar system. If it exists, Planet 9 would be a frozen giant, a world of rock and ice lurking in the perpetual twilight so far from the Sun that it would be almost impossible to spot against the blackness of space. Its discovery would force a complete rewrite of our solar system's story. How could such a large planet form so far out? Was it born there, or was it captured from another star in the Sun's infancy, making it a permanent cosmic refugee in our own family? The ongoing search for this phantom world is a modern-day celestial detective story, a perfect example of how the subtle anomalies in the motion of known objects can point the way to a monumental discovery. It proves that the frontier of exploration is not just in distant galaxies, but right here, in the silent, dark reaches of our own home, where a hidden giant may still be waiting to be found. The very laws of physics are not supposed to change. They are the bedrock of reality, the immutable rules that govern everything from the spin of an electron to the expansion of a galaxy. Yet, a shadow of a doubt has been cast by the light of the most distant objects we can see. When astronomers analyze the light from quasars, brilliant beacons powered by supermassive black holes billions of light years away, they are looking back in time. This ancient light passes through vast clouds of interstellar gas, and the atoms in those clouds absorb specific colors or frequencies, leaving a unique barcode in the quasar's spectrum. By studying this barcode, scientists can measure a number called the fine structure constant. This is not just any number, it is a fundamental coupling constant that governs the strength of the electromagnetic force. It dictates how atoms hold together, how stars burn, and how chemistry works. It is one of the handful of pure numbers that make our universe possible. The shocking suggestion from some of these quasar observations is that this constant, this pillar of physics, might have been slightly different in the early universe. The measured shift is tiny, a change of just a few parts in a million over billions of years, but its implication is staggering. If true, it means the laws of physics are not fixed. They are evolving. The universe's operating system has had a series of silent, fundamental updates. This is not a glitch in a star or a galaxy. It is a potential glitch in the very fabric of reality, challenging a principle that has been sacred since the time of Einstein. The debate within the scientific community is fierce. Other teams, using different methods or analyzing different parts of the sky, have found no such change, leaving the result in a state of profound uncertainty. If it is real, how could such a thing happen? one mind-bending explanation points to the existence of extra dimensions of space, realms beyond the three we experience. In some theories, what we perceive as a constant of nature is actually the result of the geometry of these hidden dimensions. If those dimensions were slowly changing in size as the universe expanded, then our constants would slowly change with them. We would be seeing a cosmic drift caused by the silent breathing of a higher dimensional reality. The implications ripple through everything we know. If the fine structure constant was different, then the nuclear processes in the first stars would have proceeded differently. The types of atoms forged in those stellar furnaces could change. The very possibility for life as we understand it might hinge on this number being exactly what it is today. To discover it was otherwise in the past forces us to see the cosmos not as a static stage, but as a dynamic entity whose most basic rules are part of its ongoing story. This anomaly pushes our search to the absolute limit, forcing us to ask if reality itself has a history we are only now beginning to read. These immense bubbles of pure energy are not just static monuments to a violent past. New evidence reveals they are alive with motion, fed by colossal fountains of million-degree gas erupting from the very heart of the Milky Way. These are the galactic geysers, vast streams of hot plasma being continuously blasted upward from the region surrounding our central supermassive black hole. This transforms our understanding of the Fermi bubbles from a fossil into a living, breathing entity. We are not looking at a scar from a one-time explosion, but at the ongoing exhaust of a powerful and active engine. The implications are staggering. It means the energy injection process is not a singular, ancient event, but a continuous or recurrent phenomenon. Our galaxy's core is not sleeping, it is simmering, periodically venting immense pressure and flooding its own halo with these torrents of energetic particles. This dynamic view connects directly to other central mysteries. The same colossal forces that power these geysers could be the very engine responsible for flinging hypervelocity stars across the cosmos. That gravitational slingshot which tears binary stars apart and sends one fleeing at incredible speeds requires a wildly dynamic and energetic environment, exactly the kind of turbulent cauldron that would also spew forth these vast plumes of hot gas. It paints a picture of the galactic center not as a placid place, but as a relentless forge of cosmic power, its activity cycles shaping the destiny of everything around it, from the smallest particles to the fastest stars. We are only just beginning to understand the rhythm of this great engine and what its next pulse might mean for the future of our galactic home. Even the objects visiting from other star systems can carry their own strange physics. In 2017, our solar system received its first known interstellar visitor, a small, dark object hurtling past the Sun on a trajectory that could only have originated from the void between stars. Astronomers named it Oumuamua, Hawaiian for scout, and it immediately presented a puzzle. Its shape, inferred from its wild variations in brightness, appeared to be highly elongated, like a cosmic cigar tumbling through space. But the true anomaly revealed itself as Oumuamua began its departure. Precise tracking showed it was accelerating away from the Sun, just slightly faster than the Sun's gravity alone could account for. This was a navigational glitch for an interstellar visitor, a tiny but definite push that should not have been there. For comets, such a non-gravitational acceleration is common, caused by outgassing. As the Sun's heat warms a comet's icy nucleus, jets of gas and dust erupt from its surface, acting like weak thrusters and altering its path. The problem was, Oumuamua showed no visible signs of this activity. No surrounding cloud of gas, no dusty tail, nothing. It was accelerating like a comet, but it looked like a silent, inert asteroid. This contradiction forced a scramble for explanations. The simplest answer, guided by Occam's razor, is that Oumuamua was indeed a comet, but a very peculiar one. Perhaps it was composed of very pure water ice or other ices that sublimate without releasing much dust, making the outgassing virtually invisible to our telescopes. Or its nucleus could have been unusually compact, with the gas escaping through a few narrow vents, providing a focused push without a large, diffuse coma. Still, the lack of a clear signal left room for more speculative ideas, including the notion of an artificial solar sail from another civilization. While a natural origin remains the far more probable conclusion, Oumuamua's brief passage was a profound lesson. It demonstrated that our models, built entirely from observations within our own solar system, are inherently provincial. Objects forged around other stars, in alien environments with different chemical mixes and formation histories, can have properties and behaviors we have never seen before. Oumuamua was a single data point from the galactic vastness, a hint that the catalogue of cosmic objects is far more diverse and strange than we ever assumed. Its anomalous acceleration ensures that the next time an interstellar scout streaks through our neighborhood, we will be watching much more closely, ready for the next surprise from the great dark between the stars. From the great daylight star to Oumuamua's puzzling acceleration, the history of astronomy is punctuated by these glorious glitches that defy easy explanation. Each anomaly, from a vanished star to an unexplained signal, is far more than a simple error in the data. It is a frontier of ignorance, a cosmic question mark that refuses to be erased. These are the moments where our most trusted models of the universe falter, revealing the cracks in our understanding and proving that reality is far stranger and more wonderful than our textbooks can contain. They are not failures of science, but its very engine, the unexpected nudges that push us toward new paradigms and deeper truths. As our tools grow more powerful, from space telescopes to AI-driven data analysis, we will inevitably solve some of these enduring puzzles. The ghost of Cassiopeia may reveal its full story, and the true nature of the dark flow might come into focus, but with each answer, a new and deeper mystery will almost certainly emerge from the shadows. The sky's greatest glitches are not problems to be fixed. They are permanent invitations, a cosmic call to keep looking up, to keep questioning, and to remain forever curious. For the next great surprise, the next revelation that will once again rewrite the rules, is always waiting just over the horizon.